Okay, this is problem 11 from the true-false. And they give you g of x, which is x to the fifth. And if this is g of x, then they're saying, is this true? Is this statement true, that the limit as it's given here equals 80? Okay, well, as those previous problems showed, this is the definition of the limit, this is the definition using limit notation of the derivative of g of x. The part that might be confusing you is when it's written in this form, it doesn't allow you to grind out the actual derivative, either in terms of just x or at x equals 2. However, we already know that g prime of x is 5x to the fourth. And the reason we know that is, again, using the theory of limits. But if we wanted to use the theory of limits, we'd have to go back and rewrite this as the limit as h approaches 0 of g of x plus h minus g of x. Okay, again, we're not going to evaluate it at when x equals 2. We have to find the general formula for the derivative, so we have to just use x and h and then over h. So that would become x plus h to the fifth minus x to the fifth over h. And again, this is just review now of how mathematicians discovered how to figure out derivatives so that you could later use shortcuts. But what you would find is, if you expanded this term here, you'd wind up with an x to the fifth term, but that would go away because you subtract x to the fifth. You'd also wind up with the term 5h over x to the fourth, and then you'd wind up with a bunch of other terms like, I don't know, maybe 10h squared x to the third, a bunch of other terms. But this would be the key term because this is the one time when the h in the denominator cancels out with the h in the numerator, so that as h goes to 0, this term remains fixed, 5x to the fourth, whereas a term like this, only one of the h's would cancel out and you'd be multiplying by 0. So all those other terms would go to 0. So long story short, you can find the derivative of g of x using this method, but you have to go back and plug in x's and h's, x here, to find the general formula. Or in this particular case, you just say, well, we know g prime of x is 5x to the fourth, and therefore we know that g prime of 2 is going to equal 80. That would be x to the fourth, of course, is 16, and 5 times 16 equals 80. So this is a true statement. It's just that you can't, you wouldn't be able to simply look at this and plug in g of x and get to 80. You have to find the general formula for the derivative first. But this is a true statement.